Saxon's Calculus Lesson 13 is about special functions. On page 79, they show you a whole list of different graphs. So when you have something like y equals x plus 2, you're graphing a line. When you have y equals the absolute value of x plus 2, because the absolute value won't spit out negatives, anywhere that this would have gone down into the negative half is going to skew it back up. So you end up with a V-looking graph when you're dealing with an absolute value. If the absolute value were negative, then it's going to be going down. Then they review the graph for sine of x, which you know starts in the center, and if it's positive goes up, and then you just need to do one basic curl, which ends in 360. The normal height is 1 and the low point -1. That's all they do in that one. Then they say, okay, what happens when you absolute value the sine of, oh, they used x. So then anywhere you would have had negative answers down here, they're bumping up. So my graph ends up looking like a series of humps because they all have to remain in the positives. If I make it negative absolute sign, then they're all going to land in the negatives with their humps. All right, they then show y equals x squared minus 2. Now an x squared with a plane is going to be a parabola of some sort. And then what happens when you do the absolute value of that? Well, wherever, let me fix it. Wherever I would have had answers down into the negatives, they're going to pop up. So the straight line is still coming down, but this, which was in the negatives, bumps up. And so it kind of turns it into sort of a W looking shape. And then, of course, if you negate that, then it's going to flip that so that it is down, flipping, and so they're all down into the negatives. All right, at the bottom of the page, they show you another parabola. This one just not in x squared minus 2. It's more longer equation where it's y equals negative x squared plus 2x plus 3. And you would have to complete the square to graph that parabola, but it goes back to those same shapes. They're not really showing you anything new there in what they do. So now in example 1, it says to graph the y equals the absolute value of negative sine of x. So once they've done those reviews, now you get to practice them. Since I don't have any other information with sine, I know that the center line is 0, the low point is -1, the high point is 1. Sine being negative means that I'm going to start in the center and go down first, but the absolute value tells me I can't actually go down. So let me get my 4 sections. Okay, and this is ending at 360 degrees. And so I should be going down, but that's going to bump me up. So I would have been at the low point, so now I'm going to be at the high point. So that's going to do this and this again. Because I would have been down here, then, no, down first, center, yes, up, and then down. So this one should be its normal, the up part and connecting, because that was the already positive answer. Now, we note that this is the same as the graph of y equals the absolute value of sine. Okay, whatever. Example 2. Graph y equals the square root of x. Now you need to remember that the graphing of a square root, just like an exponent, is a curvature. So I would just do my xy grid, choose some numbers, and someone, if we were in a classroom, would be yelling at me that I put a number on there that I can't put, because if I use a negative inside a square root, I can't get an answer. I've gone over to imaginary. So that's a very bad choice. So let's do 4 instead. So the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. Okay, we can graph that. 0, 0, 1, 1, 2, 3, 4, and 2. And then there is the curve, because I can't have anything below that that takes me into the negatives. Now, part B. y equals the cubed root of x. So again, I would probably choose values of 0, 1, and -1. Now don't yell at me again, because I have a cubed root, I can have negatives. So what number 3 times gives me 0? Well, it's still 0. What number 3 times gives me 1? 1. And then what number 3 times gives me -1? Well, that's -1. So 0, 0, 1, 1, -1. -1. Now this looks like a line, but I know that in a root it's more of a curve. So I might want to test, something cubed. The next one would be like 8. I don't really want to go over to the 8. You could do it on the calculator and get a decimal, but basically it's going to be the same curve kind of thing that I had here. It changes its value just a little bit because it's cubed, not squared, and then I'm doing the same thing in reverse here. So I'm just trying to match that curve basically. Now C, y equals the cubed root of x squared. Okay. When I do my XY chart, I'm going to change this to an exponent format, which means it's x squared and a denominator of 3. So anything to 0 to any power is still 0. 1 to the 2/3. Okay, 1 squared is 1. The cube root of 1 is still 1. I can do negatives. It's trickier here because I'm trying to find whole numbers. Because if I do squared, 2 squared is 4. The cubed root of 4 doesn't exist. I think I will do the negative. So then -1 is my base. Squares to 1, and the cubed root of 1 is 1. That was not too bad. So 0, 0, 1, 1, -1, 1. And I know that with the roots, they're curves. So I'm curving and I'm curving. So there's basically that graph. And you can do more dots if you wish to plug them into the calculator. I'm trying to keep it as fairly simple here as I can. Now, example 3, graph y equals, and if we got this far in the trig book, you should already recognize this as a very special looking picture. And if we didn't, then this is new. And it is the greatest integer function. And it basically means a stair step. So 0 graphs a 0, 1 graphs a 1, 2 graphs a 2. But what is happening in between these is that because it says greatest integer, integer means I can't have those fractional pieces in between. So everywhere I have a decimal in between, it is stuck at its closest one, which is 0. And then I can't have a dot and a dot here. So this one has to be a whole, but I am connecting here. Then I jump up to here and I repeat. I'm stuck here till I get to the hole at the end, and then I jump up. And then I want to do at least one backwards here so that you see I would have a hole. And so it stair steps basically. So the greatest integer factor is this stair step looking one, and we know that, we recognize it because of the symbol around the X. Now, example 4, and the final one. Write the equation of the function whose graph is. Now, this is a piecewise function because it is in 3 parts. -1, oh, no, sorry, that's an open circle. And then 1, 2 has a dot here. 3, 1 has a dot here. So this one up to the 1 was a straight line. Then it slanted and went through there and got to there, and then it straight lines again. So this is the piecewise because I've got a straight line piece, a slanted piece, and a straight piece. And it's asking for the 3 equations listing together for this picture. So for this line, it is y equals, and then where is it crossing the y line? -1. And I have to list from where does it do that. So there's a second piece to this, which is the part that lists where my x's are. So it does this y at -1 when x is greater than, but not equal to, because that was an open circle, 0. But it has to stop at 1, so it has to be less than, but that's an implied colored in, or equal to the 1. Oh, they wrote that the other way. 0 should come first, then 1. I was debating and I was trying to do it in my head. So technically this says 0 is less than the x, which is less than or equal to the 1. Technically, that's the correct order. Okay. And remember, you always read from the x. X is greater than 0, x is less than or equal to 1. Okay, now the slanted line one. Y equals, and it should be like in mx plus b. So the next thing I need is the slope. So my rise is up 1 over 1, so it's 1. And then where would this imply, like if I went down 1, backwards 1, where would I be hitting the y-axis? At -2. So I know that that will be the equation x minus 2. And then where does it do that from? So the x is in the middle. The smaller, this one's easier for me for some reason, is 1, and the larger number is the 3. So I have to be x is less than or equal to the 3. It's colored in. X has to be greater than or equal to, wait. Well, sometimes they do, sometimes they don't. They're saying if I have the or equal 1 here, I shouldn't have the or equal 1 here. Let me think about that for a split second. Is that, am I plugging in 1 and getting to this answer, or am I plugging in 1 and getting the equation here? 1 minus 2 is, I'm not. That's why. Because if I plug in the 1 to this formula, I get -3, and that's not what I'm graphing. So 1 is not part of this equation, not or equal to. And then the last one is this straight line at 1. So y equals 1. Where does y equal 1? From 3 and above. So x has to be greater than 3. Is it or equal to, let's plug the 3 in. Well, I had or equal to here, so let's see, 3 minus 2 is 1. Okay, so either way, it works okay. Oh, they don't have that. Did I just misdo it? 1 minus 2 is negative. Oh, good grief, I did. No. I'm plugging in the 3. 3 would give me 1. 3 minus 2. I would argue that you can keep the or equal in both. They're trying to say you can't have the or equal in 2 different places, but if it works the formula, yes, you can. As long as it doesn't cause a problem when plugging into the formula, you can have it in either place. So this is how I would box that answer.